Define analyticity. Okay, so here we can say that analyticity, ANALYTICITY, analyticity. It refers to a function that is differentiable in a neighborhood. The derivative exists and is continuous. All right. Remember, neighborhood means you're considering a certain range of numbers. It can be from -5 to 5. It can be from 0 to 1,000,000, right? Just because something works from 0 to 1,000,000 doesn't mean that it will work to 2,000,000. You have to consider a neighborhood. That neighborhood might even go to infinity, right? But as long as it doesn't reach a certain number, where that number is too big or too small, that it doesn't work anymore. All right, the derivative exists, you can differentiate it, and it is continuous. That means you don't have anywhere in it where you are being forced to divide by 0, right? Or anything like that. So it is analytic. The other thing is, once it is analytic, once it meets these 3 criteria, you can say that it satisfies the Cauchy-Riemann equations, right? It satisfies the Cauchy-Riemann equations. Now you're asked to determine if this function is analytic. All right, you see it there. So it is 2 to the x, the e to the 2x, so open bracket, cos y over 2 plus I sine y over 2 close bracket. All right, you use the Cauchy-Riemann equation to see if it satisfies the Cauchy-Riemann equation. I expect you to get a formula sheet with those equations. What they say is that partial derivative of u with respect to x is equal to the partial derivative of v with respect to y. Right? That's one equation. The other equation is that the partial derivative of u with respect to y is equal to the negative partial derivative of v with respect to x. Now, where do u and v come from? It's a function where z is equal to a function u of x and y, right? Plus, that's the real part, is u, plus the imaginary part, I, is v of x and y. Alright? So now, z equal e to the 2x, open bracket, z equal e to the 2x, open bracket, cos y over 2 plus I sine y over 2. Alright, so you have that there. Now, what you have here, to get it in this form, you're going to have to open the brackets. So z is equal to e to the 2x cos y over 2. So this part, the real part, u is equal to e to the 2x cos y over 2. You can see that, right? Alright. Plus I, the imaginary part, is e to the 2x sine y over 2. So v is e to the 2x sine y over 2. Okay, good. So you will have the v, the imaginary part, alright? What is delta u by delta x? If you find delta u by delta x, going to be, whatever multiply this, you'll have it there just the same, e to the, it's going to be cos y over 2 times, when you differentiate e to the 2x with respect to x, you're going to get 2 e to the 2x. You can do it by chain rule, you know. Alright? Alright, so we have delta u by delta x. That's 1. We need delta v by delta y. Delta v by delta y. What is it? If you differentiate this, you're going to have sine y over 2. When you differentiate sine of y over 2, it's the same as sine of half y over 2. The same as half y. So by chain rule, you're going to have half sine y over 2 times e to the 2x. Alright, if you simplify them, 2e to the 2x cos y over 2, and that's delta u by delta x, and delta v by delta y is half e to the 2x sine y over 2. You can see that it's not analytic. You can see it from early. Alright? You could also test it to the other equation. Delta u by delta y. So delta u by delta y. What would delta u by delta y be? Delta u by delta y. This would be half e to the 2x cos y over 2. By chain rule, half e to the 2x cos y over 2. And then what is negative delta v by delta x? Negative delta v by delta x equal. This is going to be, so delta v by delta x. So this is 2 e to the 2x. 2 e to the 2x sine y over 2. Alright. So here, so you can see from even the second equation, it doesn't satisfy. It doesn't satisfy any of the equations. So z is not analytic. All right, it's not analytic.